notation is an important way that we write very large and very small numbers. The reason it's called scientific notation is because in science we deal with things that are really, really small like atoms or really, really large like planets, and we need to be able to write those numbers in a way that doesn't involve lots and lots and lots and lots of zeros, so that it kind of condenses the number into something that we can look at. So in every kind of scientific notation, you'll have a number at the beginning with a times 10 and then an exponent. So the number at the beginning is the significant part of this number. It has to be between 1 and 9.999. All the digits here are always significant digits. The number cannot be greater than 10, it can't be less than 1, so it always has to be something point something. Then we get the times 10. The times 10 is going to give us an exponent, which tells us how many times bigger or smaller is that number. So the exponent is going to tell us how to move that decimal to make a really, really small number if it's a negative exponent, or a really, really big number if it's a positive exponent. The exponent and the times 10 are not significant figures, so it's just going to tell us how to add zeros to one side or the other of that number. So example number 1, we have 6.02 times 10 to the 13th. That means if we have a number that looks like this exponent being positive tells us we need to make that number 13 tens bigger. Okay? To do that, we have to start moving the decimal. Now, a really big number should have zeros at the end. So if I move the decimal twice to the end of the number, I've done 2 out of the 13 zeros that I need. I need to move the decimal 11 more times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I count now, this decimal has traveled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 total spaces. And we end up with a very, very large number. The decimal does not get written on the end because we don't want those zeros to be significant. So if we were to write this really nicely, it might look like this. You can put commas in between if you want, but you don't have to. So we are ending up with a very, very large number. For example 2, we have a negative exponent. A negative exponent has to be a very small number, which means that the zeros are going to come in the front of the number. So I'm going to start kind of over here, knowing I need to move that decimal 9 times. And it has to be a very small number, so I need those zeros to end up being the leading zeros in the front. So if I move the decimal once, I get here. So I need to move it 9 times total. So I've done 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to put a little 0 in each of these spots. And this time we do need a decimal, because zeros in the front don't mean anything unless there's a decimal that tells us, oh yeah, this is a really small number. So this number, if we write SE, it's going to look like this. Okay, very small number. Now, if we're looking at example 3 and 4, this time we have numbers that are written in what we call standard notation, and we want to turn them into scientific notation. So we need both of these numbers to have times 10 to some kind of exponent. Okay? So what we need to do is first of all figure out, where does that decimal go? The decimal always has to go after the first significant digit. So in example 3, the first significant digit is the 9. So I'm going to put a decimal right after that 9. That's where we want it to end up. The decimal would have started on the end of the number. It's a really big number. So I just have to count and figure out how many times has that decimal moved between the first significant digit and the end of the number. So it would have moved 1, 2, 3, 4, 5, 6, 7, 8 spots. That's why this little 8 is peeking out here. That gives me my exponent of times 10 to the 8, because the decimal would have moved 8 spots. Now when I'm trying to figure out what goes before the times 10, again, the decimal would have been behind the 9. We only want to write what would have been significant digits before we put any decimals in. So the 9, 0, and 3 would have been significant. The zeros on the end would not have been significant because there was no decimal on the end. So we have to write the 9, 0, and the 3 with the new decimal that we gave it to put it into real, correct scientific notation. In example number 4, same thing, we've got to do something times 10 to the something exponent. We can already see the decimal there, so we need to move it until it gets behind the first significant digit. So we would have to move it 1, 2, 3, 4 spots, because the 3 is the first significant digit. Since we moved it 4 spots, our exponent would be a -4. I know it's a -4 because it's a very small number, not a very large number. I only keep what's significant in front of the times 10, so all of those leading zeros I wouldn't have to write, but I'd have to write everything after that 3. So 3.15 times 10 to the -4th. Let's look at some practice problems. Okay, try question number 1 and 2. Question number 1 is a very large number. There is no decimal, so the decimal would have started on the end and moved 3, 4, 5, 6, 7, 8 spots. So our answer would look like this, 1.28 times 10 to the 8th. For question number 2, we have a very small number, so we're going to know it needs a negative exponent. That decimal would have to move 1, 2, 3, 4, 5 spots, so we get 5.64 times 10 to the -5. Going in the opposite direction, let's look at questions 8 and 9. We have numbers that are in scientific notation, and we want to put them into standard notation. So question number 8, that negative exponent tells me that it's going to be a small number. Those zeros are going to end up being leading zeros in the front of the number. So my answer would look like this. And if you look at the answer, it's because the decimal would move 1, 2, 3, 4 spots. Question number 9. We have a very large number because of the positive exponent. So the exponent is going to move those zeros to become a big number. They would have moved 1, 2, 3, 4, 5. Notice on the big numbers, I do not put a decimal on the end. The decimal just disappears once it's done its job. Now, your homework is to complete questions 1 through 14 on your own. I've already done 1, 2, 8, and 9 with you. Do not continue onto the chart with question 15 through 28. Those will be classwork altogether.